Good afternoon. My project is about IoT called by me Pineapple. What I wanted to create? I want to develop a home automation where domestic appliances are embedded by electronic sensors with network connectivity, which enable those objects to exchange data. Any user with access to this network can turn a light on and off, a heater, check the room temperature, and so on. To do so, I didn't want to restrict my users by downloading and installing a regular app in their smartphone or laptop. To overcome that obstacle, I chose to create a web app. After finishing my research regarding the feasibility of this project, I jumped into the design phase where I chose the hardwares to this project. My first choice was Raspberry Pi 3 Model 3B, a fully functional computer with low cost, which has wireless connectivity. And to communicate with the Raspberry Pi, I used the Node MCU, an open source software and hardware development environment that is built in around a system of a chip called ESP8266. In these projects, I have control over a light bulb, a heater, a door, window, the room temperature, if a plant needs water, or if there is motion in the house. But to do it, I need electronic components that will collect data or manipulate home objects. In this case, two relays modules, reed switch and magnets, moisture detector, and a motion sensor. After specifying the hardware, I had to define the programming language, network infrastructure, and user interface. But before choosing one, I attempted different approaches. Firstly, Node-RED, an open source flow-based programming tool created by IBM, where it is possible to create a network of nodes, and each node has a well-defined purpose. In this case, I had two inputs and one output to control the LED. In the second approach, it was used more nodes, but more than that, it has a web interface called dashboard. But I didn't want to choose this flow-based programming tool, neither a dashboard. I want to choose a popular programming language and create a personal user interface. So I bought a book, Learning Python with Raspberry Pi. After I developed my first web app using Flask, which is a framework, where I could control a GPIO of the Raspberry Pi and turn a LED on or off from the website. Unfortunately, I couldn't not make a bi-directional communication in this app, and I was having problems understanding JavaScript. So I decided to learn JavaScript to use it in the back end instead of Python. So I would use Node.js, which is written with JavaScript in the back end and JavaScript in the front end. My first attempt with Node.js was with Socket.io for a bidirectional communication and using HTTP for request and response. It worked very well. But after further investigation, I found out that using HTTP it could be a problem if I wanted to expand my IoT network. The alternative to that issue was to use mqtt, messaging queuing telemetry transport, which is a lightweight message protocol. I found sources affirming that it consumes 11 times less energy to send a message than HTTP, 107 times less than to receive, and it is 93 times faster. In the example produced in the image below, the example produced is the publisher, the consumers are the subscribers. So when the producer sends a message to a specific topic in the broker, all the consumers will receive that message. So it is how the mqtt broker works. In this approach with mqtt, I had 2 clients and 1 broker in the Raspberry Pi. The mqtt broker message used in the Raspberry Pi was the Mosquito, and in the laptop I used the Eclipse Paro. And the mqtt it was just imported a library. When I press the button on the web page, the JavaScript will connect to the broker and you send the message that turn the LED that send to the topic and turn the LED on. In the implementation of so I implemented a similar approach but using a web server with the Node.js, where I have 1 subscriber, which is the LED, connect to the LED, 1 publisher, which is the temperature sensor, and the server is both subscriber and publisher. Assuming they are all connected to the Wi-Fi, the temperature model will send a temp message to the topic called room temperature in the broker. So the mqtt client that is subscribed to this temperature topic will display the temperature